This video will cover topic 1.3 of the Year 12 Physics, and in particular gravitation. The following outcomes are required by SACE, and you can pause the video for a closer look. Every particle in the universe is attracted to every single other particle in the universe, just based on its mass, and this is what gravitation is about. Now, the size of this force depends on a couple of factors. So it's the mass of the objects and also the distance between them. And this force acts in a straight line between the two objects' center of mass. The force that's experienced is actually experienced by both masses, and the magnitude is based on the product of those masses. So that means if there's a larger mass, there's going to be a bigger force between the two objects. The distance between the two objects is also important. The further the distance, the less force is going to be experienced by the two objects, which makes sense. So you're going to see this proportional symbol being used, and it's kind of like an infinity symbol with the end cut off. Not to be confused with the alpha, which is slightly different. Now, because the squared component is there for the distance between them, what that means is it has a really big influence on the force, meaning if you double the distance between two objects, because it's squared, it'll be 4 times less force. And you can keep going with that. So if it was 3 times more, you'll have 3 squared, being 9 times less force than in like a base case. So combining these two relationships, we can see that we can get a formula where force between the two objects is equal to the product of the masses times a gravitational constant, which is denoted as g here. And because it's a constant, g is that value there, and you can find that on your formula sheet, divided by the distance squared. Okay, so see if you can find this formula on your formula sheet. When using the formula, it's important to remember, especially when we're working with really large objects like planets, we're going to treat the objects as point masses, meaning the mass is just concentrated at one point in the center of the object. So that's what we call the center of mass. Don't forget to take this into account when you're measuring the distances. Okay, I want to do this a little bit more in class and talk about proportionality, but just for this video. Okay, if we have a mass 1, mass 2 separated by a distance r, the force is given by F. If we have another scenario where we double the mass, so one of the masses, say m1, is doubled, what happens there is the force is also doubled. And we can do this, we can see this without having to do any extra calculations, but just by recognizing its proportionality. This also applies to the distance between the two objects. So if we have the radius that's doubled, because of that square term, the force is actually 4 times less than that original case. Okay, let's take a look at an example of an object in Earth's gravitational field, and it's falling towards Earth. It's under the influence of gravity. So the force on that object is denoted with this first formula here, and that's the force between the Earth and the object. So you can see that we've got the mass of the Earth, the mass of the object, and the distance between them. But this force that the ball experiences can also be denoted by F equals ma. So that's Newton's second law. And rearranging, you can see that acceleration, which is gravity, is equal to the force divided by the mass. And this particular m here, that's the mass of the object. Okay, so if we know those two forces are equal, we can equate this first equation and this equation here. So what we would have is F equals ma over here is equal to this component. So what happens is when we equate them, this m over here, which is the mass of the object, because it's on both sides of the equal sign, it disappears. So we're left with this formula here. Now this is the acceleration of an object on Earth. And you can see it actually doesn't depend on the mass of the object itself, because that little m disappeared. It's not in the formula. So the acceleration of the object on Earth is actually just due to the distance the object is away from the center of the Earth and the mass of the Earth itself. So running through some values, which you can see that we've got up here, the gravitational constant, the mass of the Earth, and the distance from the center of the Earth to the surface, you can see we get the value of 9.8 meters a second squared, which we know is the constant for gravity on Earth, on the surface of the Earth.